Hello everyone, this is Michael, and here is 3 minutes of AI. Have you ever wondered if foundation models that we all know from generative AI, language models, and multimodal models, if those ever made their way into other fields of AI, like let's say robotics? And in this video, I want to answer you and give you an example of what is happening out there, particularly with robotics. So there's more foundation models than just the ones that we use every day in our generative AI platform. And the example that I want to bring up is RTX. So what DeepMind did is they developed a foundation model sort of for robotic tasks. And this comes by collecting data from 22 different robot types out of 33 academic labs, as you can see. And this together for many tasks produces a vastly huge data set because we have 150,000 tasks and then more than 1 million episodes. This is a huge data set, and you can now imagine if you now train a model with that, this becomes a new foundation model that is focused on robot tasks. But how good does it do? And the interesting piece is that they trained with this new data set that is called RTX, a foundation model, and applied this to the different robots that were used in the data set, but also gave it some new tasks. And the results are astonishing. Now you see, the data set is very vast and it learns about a lot of tasks, and they applied this. And the interesting thing is that applying the foundation model onto the individual tasks with these different robots resulted in better results than the optimal models that were found before that were trained only on this task for this robot. This means the generalization from a lot of data helped it to outperform what was there before as an expert model. Very interesting finding. So now we see this is what happened with RT1X. There's also RT2X. I will get to this later. There's two different models that were trained as foundation models. Now, on top of that, we also have emergent skills. Now, what do these mean? In this case, it's very much about mapping language understanding onto location understanding, onto real-world understanding. And what is happening here is that you can state something in language that describes a location. This can be between apple and can and orange. And interestingly, this model figures out what this means and translate that into an action to move something into this location. This is one of the emergent skills. It generalizes as well quite well for new tasks that with unseen objects or with a robot that have not been in the data set before. So that is another very interesting result, that it generalizes beyond or out of the distribution of the data set that is seen. If you want to read more, there's more than just this blog post, which I will put into the links again. You can also read a little micro page on this result, which is quite interesting. Also explains these models RD1X and RD2X, where you see how those works, that they contain enriching components like the vision transformer and a large language model, and they explain you also which one it is. And you find, of course, all the details in the paper, together with a nice conclusion and outlook where all of this is leading. And we also see some experimental results on unseen object backgrounds and environments. And I promised that I also explained what RT2 is. So very quickly, RT2, that is an architecture that was used here. That was the first result that showed really good generalization by learning from a lot of data. This led to our vision language action models, VLA, that understand vision and the language instructions and can turn this into actions, and already showed very good generalization capabilities. I'll put the link for RT2 also in the description. Check it out. It's worth a read, and the paper is quite interesting as well. Bye, everyone.